Hey guys, welcome back to Helper Function. In this video we will discuss a question, power of 2. So the problem is pretty straightforward. Given an integer, write a function to determine if it is a power of 2 or not. So we just need to return true if the number is power of 2, otherwise false. So for the numbers like 1, 2 and 64, as they can be represented as 2 to the power 0, 2 to the power 1 and 2 to the power 6 respectively, we will return true. And for the numbers like 0, 13, 62, they are not a power of 2, so we will return false. So let's see how we will solve this. Now the most basic approach is to check for all power of 2's. We'll take an integer and initialize it to 1 and we'll keep multiplying it with 2 until it becomes greater than n. Meanwhile, every time we multiply it with 2, we will compare it with n. Now if they are equal, it means that it is a power of 2 and we will return true. Otherwise, the number will become greater than n and the loop will terminate and we will return false. So here's the code for that. We declare a long int answer and initialize it to 1. We have taken long int to avoid overflows. Now this while loop will work until answer is lesser than equals to n. So every time in a loop, if my answer is equals to n, we will return true. And also every time answer gets multiplied by 2. Now if answer becomes greater than n, we will come out of this loop and will return false, which means that the number is not a power of 2. This approach works fine, but we have another approaches which can give the solution without using loops. One observation is that if a number is a power of 2, then the number of set bits in its binary form will be 1. Now set bits are the bits with value 1. This is because in the binary form, every bit is represented as a power of 2. So for a number to be a power of 2, the number of set bits should only be 1. So the solution to our problem would be to count the number of set bits in n, and if it is 1 then return true, otherwise return false. Now there can be different methods to find the set bits, but C++ has a predefined function called built-in pop count which returns the count of set bits of a number. So if this function returns 1, this means that the number of set bits in n is 1, and hence we will return true, and otherwise we will return false. Now note that n greater than 0 is the primary condition for checking the power of 2, as a number lesser than or equals to 0 can never be a power of 2. Now another observation is that for n the number of set bit is 1, but if we look at n minus 1, we will see that all the lower bits are 1, and the bit that is 1 in n will be 0 in n minus 1. Thus doing a bitwise AND operation between n and n minus 1, we will get 0. Because AND operation gives set bit only when both the bits are set. But here in the figure we can see that no bits are set for both n and n minus 1. Thus if a number is power of 2, then the bitwise AND between n and n minus 1 is 0. And here's the code for that. If n is greater than 0 and bitwise AND between n and n minus 1 is also 0, then we will return true, otherwise we return false. So the time complexity for this problem is order of number of bits, which is very small and vary between 0 to 32 for a 32-bit integer. And the space complexity is constant as we are using no extra space. So these were the different ways how we can approach this problem. If you like this video, then do like, share and subscribe to the channel. Thank you for watching.